The sun. The sun, the hearth of affection and life, pours burning love on the delighted earth, said Arthur Rimbaud. It's the heart of our solar system, a blazing sphere of hot gas that dominates the sky. Every day we feel its warmth and see its light. This giant star is the reason we exist. The sun's gravity holds everything together, keeping planets in their orbits. Without the sun, there would be no solar system, no Earth, no us. Often taken for granted, the sun is a powerful force of nature. Let's explore the epic story of the sun, from its fiery birth to its eventual fate. Are you ready to explore? Let's begin. Look up at the night sky. On a clear night, you'll see countless stars. Each one is a sun, a giant ball of burning gas. But to us, the sun is special. It's our star, the one that gives us life. The sun is a G-type main sequence star, about halfway through its life cycle. It's been shining for billions of years and will continue for billions more. Scientists study the sun constantly to understand its behavior and its effects on our planet. By studying it, we learn more about the universe as a whole. We gain a deeper appreciation for our place in the cosmos. The sun is more than just a source of light and heat. It's the engine that drives all life on Earth. Without the sun, our planet would be a frozen wasteland. Plants use sunlight to produce energy through photosynthesis, the foundation of the food chain. The sun also drives our weather patterns, causing winds and ocean currents. Human civilization has always been linked to the sun. Ancient cultures tracked its movements and worshipped it as a god. Today we understand the sun in greater scientific detail, but it still inspires us. It's a symbol of hope, power, and life itself. Before our sun blazed in the sky, there was a vast cloud of gas and dust. This molecular cloud drifted through space, holding the seeds of stars. Gravity slowly gathered the scattered particles, pulling them towards a central point. Imagine this cloud, a swirling mass of hydrogen, helium, and heavier elements. Over millions of years, the cloud collapsed, spinning faster and growing denser and hotter. The center of the cloud, the focal point of this gravitational collapse, became a protostar. This dense, hot core was on the verge of bursting into life. The stage was set for the birth of a star. Deep within the collapsing cloud, the proto-sun began to take shape. Gravity drew material inward, increasing the density and temperature at the core. The proto-sun, still shrouded in the molecular cloud, glowed faintly. The collapsing cloud fragmented, forming smaller clumps that would become planets, moons, and asteroids. As the proto-sun contracted, its rotation accelerated, generating intense magnetic fields. These fields influenced the formation of the planets and shaped the early solar system. The proto-sun continued to grow, drawing in more material from the surrounding cloud. The stage was set for the dramatic ignition of nuclear fusion. Deep within the proto-sun, temperature and pressure reached a critical point. Hydrogen atoms began to fuse, igniting nuclear fusion. This was the birth of a star. The proto-sun roared to life, pushing back against the infalling material with intense radiation. This ignition marked the beginning of the sun's main sequence, a stable period of hydrogen burning. The sun became the dominant force in its newly formed solar system. Its energy bathed the surrounding planets, providing the light and warmth necessary for life on Earth. The sun's dramatic birth laid the foundation for everything we know. Let's journey into the heart of our star, the sun's core. Here, temperatures soar to 15 million degrees Celsius. It's in this inferno that the sun's energy is generated through nuclear fusion. Hydrogen atoms collide with such force that they fuse, creating helium and releasing tremendous energy. Every second, 600 million tons of hydrogen are converted into helium. This energy sustains the sun's enormous output of light and heat. Think of the sun's core as a giant furnace, constantly churning and burning. This energy then begins its long journey outward, eventually reaching us as sunlight. Layers of light journey outward. From the sun's core, energy embarks on a remarkable journey outward. This journey is a complex dance of absorption, re-emission, and convection. The energy passes through the radiative zone, where photons are constantly absorbed and re-emitted. This process can take hundreds of thousands of years. The energy then reaches the convective zone, where heat is transferred through convection. Finally, the energy reaches the photosphere, the visible surface of the sun. From here, the sun releases its energy into space, bathing our solar system in light and heat. The sun's breath, solar wind. The sun emits a constant stream of charged particles called the solar wind. This wind travels at speeds of up to 800 kilometers per second. Imagine a constant breeze of charged particles flowing outward from the sun. This solar wind interacts with the magnetic fields and atmospheres of planets, creating auroras and influencing planetary evolution. On Earth, our magnetic field protects us from the full brunt of the solar wind. However, some particles can penetrate, leading to geomagnetic storms. The solar wind is a constant reminder of the sun's power and influence. A restless giant, sunspots and solar flares. The sun is a dynamic and restless giant with a constantly changing surface. Sunspots are areas of intense magnetic activity appearing as dark blemishes. Solar flares are sudden bursts of energy that erupt from the sun's surface. These eruptions release vast amounts of energy, disrupting radio communications and damaging satellites. These dynamic events remind us that the sun is a powerful and complex object. Understanding these solar events is crucial for predicting space weather. They impact our technological infrastructure and our daily lives. The sun, a blazing sphere of hot gas, sits at the heart of our solar system. Its immense mass creates a gravitational field that holds the solar system together. Imagine the sun's gravity as invisible threads, connecting it to every object in the solar system. These threads are a powerful force, keeping objects from flying off into space. The closer an object is to the sun, the stronger the pull. This is why the inner planets orbit the sun much faster than the outer planets. The sun's gravity shapes the orbits of planets, comets, and asteroids. It influences their paths and evolution over billions of years. Under the sun's gravitational influence, the planets engage in a celestial ballet. Each planet follows a specific path called an orbit around the sun. Imagine the planets as dancers, each moving to the rhythm of the sun's gravitational pull. The inner planets move with a quicker tempo, completing their orbits in months. The outer planets move at a more stately pace, their orbits taking years or decades. This celestial ballet is a highly ordered system, governed by gravity and motion. The planets move in predictable paths, their speeds and positions determined by their distance from the sun. This cosmic dance is a testament to the power and precision of gravity. The sun's influence extends beyond dictating the orbits of planets. It plays a crucial role in shaping the physical characteristics and evolution of the solar system. Imagine the early solar system, a swirling disk of gas and dust surrounding the newborn sun. The sun's heat created a temperature gradient, with the inner regions much hotter than the outer regions. This temperature difference determined the composition of the planets. In the inner solar system, heavier elements like iron and rock formed the rocky planets. In the outer solar system, lighter elements like hydrogen and helium formed the gas giants. The sun's gravity also shaped the surfaces of planets and moons, influencing their evolution over billions of years. Beyond the planets, the sun's influence extends far into the vast expanse of space known as the interstellar medium. This region, the space between the stars, isn't empty but filled with a tenuous gas and dust. The sun's gravity and radiation play a significant role in shaping this environment. Imagine the solar wind, a constant stream of charged particles flowing outward from the sun as a powerful wind pushing against the interstellar medium. This interaction creates a bubble-like structure called the heliosphere. The heliosphere acts as a shield, protecting our solar system from some of the harmful radiation from interstellar space. The sun's gravity also influences the motion of comets and other icy bodies in the outer reaches of the solar system, sometimes nudging them into orbits that bring them closer to the sun. As these icy bodies approach the sun, they heat up, releasing gas and dust that create the spectacular tails we associate with comets. The sun's reach, therefore, extends far beyond the familiar planets and moons of our solar system, influencing the interstellar environment and shaping the paths of celestial wanderers that venture near. It's a reminder that our solar system is not an isolated island in space, but part of a larger cosmic tapestry, constantly interacting with its surroundings. Our planet Earth, a vibrant oasis in space, owes its climate to the sun, a celestial furnace millions of miles away. The sun's energy reaches Earth as sunlight, warming our planet and driving atmospheric and oceanic currents. Uneven heating creates temperature differences that drive atmospheric circulation. Warm air rises at the equator, flows towards the poles, cools, and descends, creating global wind patterns. These currents influence ocean currents, regulating Earth's climate. Warm ocean currents transport heat, moderating temperatures in higher latitudes. Cold currents bring nutrient-rich waters, supporting marine ecosystems. The sun's energy drives Earth's climate, creating conditions for life to thrive. Understanding the sun's influence is crucial for predicting and mitigating climate change. At the heart of Earth's vibrant biosphere lies a remarkable process that transforms sunlight into chemical energy, a process that sustains virtually all life on our planet, photosynthesis. This process, carried out by plants, algae, and some bacteria, captures the sun's energy and converts it into a form that can be used by other organisms. Imagine a single leaf bathed in sunlight, its cells teeming with tiny organelles called chloroplasts. Within these chloroplasts, a remarkable transformation takes place. Sunlight is absorbed by chlorophyll, a green pigment that gives plants their characteristic color, and this absorbed energy is used to power a series of chemical reactions that convert carbon dioxide and water into glucose, a simple sugar that stores energy. This process, photosynthesis, is the foundation of most food chains on Earth. Plants, through photosynthesis, convert sunlight into chemical energy stored in glucose, and this energy is then passed on to herbivores that eat plants and carnivores that eat herbivores. Even decomposers, which break down dead organisms, rely on the energy originally captured from sunlight through photosynthesis. Photosynthesis, therefore, is a vital link between the sun and life on Earth. It's a process that transforms sunlight into the energy that sustains entire ecosystems, a testament to the sun's crucial role in making our planet a vibrant and teeming biosphere. The sun, a celestial beacon in our sky, has captivated human imagination since the dawn of our species. From ancient myths and legends to modern scientific endeavors, the sun has played a central role in human history and culture, shaping our understanding of the universe and our place within it. Imagine our ancestors gazing up at the sky, awestruck by the sun's brilliance and warmth. They recognized its importance for life, for agriculture, for the cycle of day and night. The sun became a central figure in their myths and religions, often personified as a deity, a source of power and creation. Ancient civilizations, from the Egyptians to the Mayans, tracked the sun's movements with astonishing accuracy, building elaborate structures to align with solstices and equinoxes. These celestial alignments served not only as calendars, but also as expressions of their worldview, connecting them to the cosmos and reflecting their reverence for the sun. Even in the modern era, with our scientific understanding of the sun's nature, it continues to inspire art, literature, and music. The sun's energy, warmth, and life-giving properties continue to resonate with us on a deep level, reminding us of our connection to the cosmos and the awe-inspiring forces at play in the universe. Our sun, the anchor of our solar system, may seem eternal, but even stars have a lifespan. The sun is engaged in a delicate balancing act, with gravity trying to collapse it and nuclear fusion pushing back. But this balance cannot last forever. As the sun burns through its hydrogen, the core will contract and heat up, igniting helium fusion. The sun will expand into a red giant, engulfing Mercury and Venus, possibly reaching Earth. This transformation is a natural stage in the life cycle of stars like our sun. It's a reminder of the dynamic and ever-changing nature of the universe. Even as our sun approaches its fate as a red giant and ultimately as a white dwarf, Its legacy of light and life will extend far beyond its own existence. The sun's death will seed the interstellar medium with heavier elements, the building blocks of future stars and planets. Imagine the sun as a red giant, its outer layers shedding into space, carrying elements forged in its core, carbon, oxygen, nitrogen. These elements will become part of new stars and planetary systems, enriching the universe with the ingredients for life. The sun's death is not an end but a beginning, a continuation of the cosmic cycle of stellar birth, life and death. Thanks for watching. Please subscribe to support our channel. Peace and love to all.